Hello and welcome back to QuickType Inside Out, where we look at QuickType and its implementation. This is episode 2. We had originally planned to do an episode 2 much earlier, where we wanted to show you how to implement a new support for a new target language. However, in the meantime, we decided to completely rewrite our backend architecture. Now, there is a law somewhere that says you shouldn't do complete rewrites. So let's take a look at the reasons for why we did that. First of all, our naming system was a really big kludge or actually we had to use lots of kludges to make it work. And it was a big blocker on a few issues, and I'm going to talk about that in detail, but we could have rewritten it individually without doing everything again. So it's not the best reason. And there were lots of smaller issues. For example, we wanted to be able to give issues and warnings about specific parts of the output to the user. But we could have built that in. We didn't have to completely rewrite the backend. But there is one very good particular reason for doing a complete rewrite, namely the current or now old backend infrastructure was written in PureScript, which is essentially Haskell that compiles to JavaScript. But we are an open source project and we really want people to contribute, and in particular to contribute support for new target languages. But nobody knows PureScript, and PureScript is really, really hard to learn. And so we just could not expect many people to contribute realistically. And so therefore, we did a complete rewrite in TypeScript, which is basically JavaScript with a static type system. And we fixed all the issues that we had, and we thought about other stuff that we might want to support in the future. And we thought about an architecture that will support that in a nice way. And of course, the TypeScript community is much larger than the PureScript community. And in addition to that, TypeScript is pretty easy to pick up for JavaScript developers, of which there are literally millions. And in any case, for almost anybody, it's easier to learn than PureScript. So there we are. We are going to start actually implementing a new target language in the next episode. But in this episode, I just wanted to talk a little bit about the issues that we were trying to solve, or that we actually solved, because the infrastructure is basically done. We already have a pull request. The C# renderer is implemented. So basically now we have the C# renderer implemented in the new rendering engine, in the new backend engine. It's already feature complete, passes all the tests. There's just a few finishing touches. We need to support it in the web UI, but it should land pretty soon. And so, as I said before, in the next episode, I want to start showing you how to implement support for C++ in this case, because we don't support that language yet. We will, by the way, of course, still keep all the old target languages that we support around. It's not like anything's going to go away, but we're going to slowly switch over to the new infrastructure. So the biggest issue that I mentioned before, the biggest technical issue was naming things, and it was a blocker on a few issues. And what I mean by naming things is, how do you name the classes in the generated code? How do you name the properties? And it seems like an easy problem, but it is not. And one of the main uh, issues that people complained about was that in some languages, for example, in Go, in Elm, and in Swift, we did this really ugly thing of defining this type alias for the top level type. So basically, you say, um, I want the type for this thing to be named Pokedex. And so you would expect that it would actually name this class Pokedex. But no, what we actually do is we introduce this type alias called Pokedex, and then we name the class or the struct in this case, other Pokedex. Why do we do that? Are you stupid? Well, no, we're not stupid. It's really complicated. There is an issue if you wanna read um, all the fine details. It's issue number 102. But I can give you a short summary. So when we name classes in the old system, we basically have a thing that goes through all of the classes. Each class has a name that it prefers, and so each class gets ideally the preferred name. If the preferred name is not available, we other it. And our othering algorithm currently, all it does is it prefixes the name with other. And you can tell the naming algorithm, listen, here's a few names that you cannot use. Those would be reserved keywords or names of other things that you want to define yourself. So because this thing will just go through the classes one by one and potentially change the name, you can't guarantee that a specific class will get a specific name. So to make sure that the top level really has that name, we need to reserve that name in advance and say, look, don't name any class that. I want that name to be reserved. And we can tell it, look, this class needs to be that name. It's just not supported in the naming system. And we could have put kludges on top of kludges to make that work, but there were other issues with the naming system as well. So a rewrite of it had to happen anyway. And so we did that in the context of this complete new rewrite. But there's a few nice things that fall out of the new system that we use for naming. One of them is that in the new naming system, every entity that gets a name is explicitly represented. So the naming thing, the named thing itself, has a representation separate from the thing that is actually named, if that makes any sense. So kind of the name to be is explicitly represented, and the whole thing is a graph because there can be dependencies between names and stuff. And one of the things that will allow us in the future is to be able to give the user the opportunity to actually override names and not just the top level name. Like you'll be able to say, you know what, I actually want this to be not named next evolution, despite this saying next evolution, I want it to be called something else. And we don't know how we're going to do that yet. Is it going to be a config file? Is there going to be a UI? Are you going to be able to just click here and put in another name and all the names will change automatically? The thing that's important is we have that infrastructure now. We can do it if we want to. We didn't have that in the old system. So that's pretty cool. Another thing that that we wanted to have in a new system was the ability to tell users about issues in the generated code. In particular, issues where we had a pretty good hunch that the code that we generated wasn't complete or correct. In particular, I'll give you two examples that are kind of the ones where we can definitely tell you something's amiss. Is, let's say you have an attribute that is just an empty array. And let's switch to, I don't know, C#. And what we do here is we don't know what kind of type should be in there. We literally have nothing, right? So we just put in object. But we would like to tell the user, look, you should really look at this. We don't know what to do with this. But right now, we don't really have a good way. We could put in a comment, but maybe users are not going to look at that. And as I said, there's no infrastructure in the old architecture, but now we have it. And we don't have the warnings yet, but we have a way to put them in a really nice way. Another case where that would happen was you could have an attribute that was just null, in which case we also generate object, because it's unlikely that in the data format that you get, this attribute is always null. Maybe it is, but there's probably some cases where it's not null, but we don't see them, so we have no idea what that should be. So we would like to tell the user, look, this probably shouldn't be object. You might want to, either give us more data, or you might want to fix it manually, whichever way you want. Another thing that would be nice to have is the ability to, let's go to another one, let's go to this one. To be able to inquire, let's say, where this thing comes from, right? I could look through the source here, and I could search in it, but maybe there's more than one thumbnail with. It might be really hard to find where this originates from, but it would be really nice if we preserved all of that information going from the original JSON all the way to the generated code. So you could just click there and it could show you this is where it's coming from. Or, go the other way around, click on self-text HTML and see in the generated code where it is. We don't have that feature yet in the new renderer, but we have the infrastructure at least to put it in. And actually, the infrastructure for both this provenance, as I call it, as well as for the issues and the warnings, is the same mechanism. So what we have in our representation of generated code is we can put attributes on parts of the code. And one of those attributes could be, look, this text has an issue associated with it, so please tell the user. Or this text comes from this part of the original JSON, so when the user clicks on it, please tell them. So yeah, that's it for the most part. I'm not going to show you details of how that works. We're going to start looking at that in the next episode when we will actually implement, as I said, a C++ backend. So see you then.